Hi, I'm Izzy Morin, and I'm an undergraduate student in the Sustainability and Contemporary Studies departments at Dalhousie University and University of King's College. I'm also a cluster student at Situating Science. This is the first episode in a series of podcasts complementing the upcoming Hype in Science event, happening at the University of King's College on December 7th. So, today we are talking with Dr. Ford Doolittle, who is a professor at Dalhousie University in the Department of Biochemistry and Molecular Biology. His current research is in the field of the evolution of genes and genomes. He is also the coordinator of the upcoming Hype in Science event at University of King's College on Saturday, December 7th. Hype in Science, or How Can Respectable Journals Publish Such Crap, will take the shape of 6 case studies of overselling, misrepresentation, or biasing in the presentation of scientific research. Voices from Harvard, UBC, Elsevier, and Dalhousie will be presenting case studies from their own fields and fueling discussions by casting a critical eye towards the peer review process. The process of the rise of a paper to celebrity status will also be under scrutiny. Is the search for breakthrough papers verging on fetishism? And how will trustworthiness in research be ensured in the context of the current collapse of the peer review system? Dr. Doolittle's talk, titled Is Junk Bunk? Panadaptationism and Functional Genomics, will be a discussion of the pressure around researchers seeking funding and breakthrough-hungry journals. The current controversy around junk DNA will be used as a case study to explore the politics of fact establishment and systemic ignorance. Specifically, Dr. Doolittle will be speaking to the notion of junk DNA as having been debunked only because of the ignorance of traditional definitions of biological function and the ignorance of much of the existing comparative genomic literature. So, Dr. Doolittle, could you give us a brief snapshot of what junk DNA actually is?
Well, junk DNA is it's an idea, and it supposedly, and I believe that it does refer to about the majority of our own genomes in particular, and the idea that much DNA was junk was first proposed in the 1970s when it was realized that different organisms have vastly different amounts of DNA, and that differences in amount don't seem to correlate with anything that you might call complexity. So the favorite example of most people is the lungfish has 40 times as much DNA as we do, and most people would not think that the lungfish was 40 times as complicated or interesting as we are. And there are, within groups of organisms, vast ranges of DNA contents of organisms that otherwise look exactly the same, almost. So the idea was, well, this DNA must not really be doing anything. Most of this excess DNA must be junk, in the sense of not being put there by natural selection to serve the interests of the organism.
So the claim that 80% of the human genome is functional is being used in conjunction with the debunking of the theory of junk DNA. In your talk, you are suggesting that this process is fueled at least partially by the ignorance of traditional definitions of biological function. Could you speak to the origin of systemic ignorance in this context?
It's hard to know where ignorance arises. I mean, I think, and this is one thing that we're investigating now, I'm not really quite sure how we're going to find this out. I think the word function has been used differently by different subdisciplines of biology for a long time now, at least for decades. And so for an evolutionary biologist, function really does mean what it was put there for. And one of my favorite examples was a long passage from John Maynard Smith where he describes the fact that horses have very straight backs, and as a result of that, people can ride them, but we don't think that the function of a horse's back is to be ridden because we don't think that horses evolved with their straight backs in order that we could ride them. And so I think the biologists, and the evolutionary biologists in particular's definition of function would be that it is the trait, it is the reason that natural selection created and maintains that trait in organisms. And that's what's called the selective effect definition of function. And I think it's what most people mean when you say, what is the function of this biological thing? However, when you actually do much of modern biochemistry, molecular biology, or genetics, you don't actually ask that question. You ask, how does part A interact with part B to produce effect C? And you might not even know that effect C is of any benefit to the organism, but you would still say that the function of A and B is to produce C. So that way, then you can talk about, for instance, the function of diseases, the function of certain genes in the generation of cancer. But you wouldn't say that the function of a gene was to cause cancer in humans. I mean, nobody would say that. So both the meanings of function are illustrated by that example, I think. And I think genomicists have and genomics and modern systems biology very much ignore the evolutionary explanations.
In this context of changing definitions, do you think there's any possible saving grace for the peer review process to address this kind of systemic ignorance?
Oh, sure. Well, I mean, I think that the whole problem around ENCODE really was that they were using one definition of function to refute a concept which was based on a different definition of function. So in a way, that's kind of dishonest. I mean, if you say X is Y, but you have some concept of what you mean by that, and I say, well, X is not Y, but I'm using a totally different measure, and it doesn't actually relate to your understanding, then that's a dishonest thing to do. And I think that the ENCODE people, perhaps not deliberately, did that, and the reason that was done is because then Nature could publish a paper saying there is no junk DNA, because this was a contentious issue for a long time. So that's where the hype comes in, is the appeal to the journals, particularly the major high-profile journals, to publish things which appear to be revolutionary or paradigm-breaking, and yet when you look at them carefully, you realize, well, it only appears to be that way because they've redefined the term or something like that. And I don't think I'm answering the question you asked now, but peer review could have changed that quite a lot. I think if they'd sent those papers out to more people, they sent it to me, for instance, I would have argued against this. Interestingly, when the ENCODE papers came out, and I'm sure other people wrote to Nature and said, well, hey, we don't really think this is the right way to talk about function, so I'd like to write a little critique of this and publish it as something. And they wrote back and they said, well, we don't think this will be of general interest, which is what journals usually say when they don't want to publish something. And in fact, it turned out to be one of the more controversial papers that they'd published in a long time, set of papers. So journals are not into criticism these days.
Do you think there are any possible replacements for the peer review process to ensure the trustworthiness of published papers?
So again, I don't think it's particularly the peer review process that failed here. It was the probably selective choice of peers who they thought would be sympathetic to this way of producing things, and the subsequent publicity that they allowed to build up around this. I mean, the peer review process is deeply flawed in a way. I mean, I'm an editor of journals, and I send out manuscripts to be reviewed, and so quite often they'll come back with one reviewer thinking it's the greatest thing since sliced bread, and the other one thinking it's garbage. And then I, as an editor, have to decide, well, am I going to go with the one or the other? Am I going to send it out to a third person, hoping to get at least two people on one side or the other? So you soon enough get to realize that, well, there's a lot of randomness in this, and it's not so surprising. I mean, if the paper is interesting at all, it will probably have an interpretation that is complicated and possibly wrong. So I don't see any other system but the peer review system. I mean, I think, but it's very burdensome now, because you get, every day I get, and I think most senior scientists get, more requests to review manuscripts than they could possibly handle if they want to do anything else. And so it's not the workload is poorly distributed, and you don't get paid for it. And, the system is, there are too many papers being published and being reviewed by too few people who are too angry about having to do this all the time. So,
just back to the topic of seeking breakthroughs. In the context of journals seeking out paradigm-shifting breakthroughs from researchers, could you comment on the ignorance of existing comparative literature and the discussions surrounding the breakdown of the junk DNA theory?
Well, I think it's interesting that probably the people that whose backs were gotten up by the paper were older people like me who remember the 1980s when this whole issue was debated before. So that is another thing that you commonly see, is that a paper comes out and makes some radical claim, and an old guy like me will say, well, that's not a radical claim. Joe made that 10 years ago, and then, or 30 years ago, somebody said exactly the same thing, and then people argued this and they argued that, and here's how it came out. And it's as if the journals and the authors, of course, many of whom were not born then, don't know, and also don't feel any obligation to look to see whether or not this debate has already been had. So there's a deja vu about many things. Of course, the older you get, the more you've seen. But
do you think that there's too much information in one field for researchers to have any kind of historical memory of these kinds of, recurring breakthroughs?
Well, yes, there's a ridiculous amount of stuff that you have to know these days, but there's also within science an ahistorical or an anti-historical bias. I mean, I think scientists are taught that, well, here's the facts, and how we got the facts, it might be amusing, but it isn't really relevant because now we know the facts, so we don't have to know what we believed before because now we've got the truth. And it's interesting, well, I went to NASCAD for a while, and it's interesting how art history plays a role in actual art, whereas science history plays almost no role in the training of scientists. I think there's an interesting contrast there. And, an interest in the history of your own science is often taken as a sign of that you're past it and you can't actually do science anymore or something like that. So there's definitely a prejudice, and I think it leads to a certain amount of dysfunction in the discipline because people aren't aware of issues that have already been dealt with, or that people aren't aware of already settled questions, or at least aren't aware of the arguments that have been raised before and will have to be dealt with again. So.
Well, thank you so much for chatting with us, Dr. Doolittle, and thank you to everybody who's tuning in. For more information on Situating Science and the Hype in Science event, visit our website at situsci.ca. That's situsci.ca.